the universe and physics. Are we living in a simulation? A stunning scientific and philosophical analysis that overturns our concept of reality. Have you ever wondered, even for a fleeting moment, if your daily life, with all its intricate details and intertwined events, is nothing more than an incredibly complex computer game or an elaborately designed computer program run by an unseen entity? This idea might seem to come straight out of a Hollywood sci-fi movie or a short story by Philip K. Dick, but in reality, it's not at all. It's the core of the simulation hypothesis, a serious scientific and philosophical premise that garners deep interest and intense debate among some of the brightest minds in technology and physics, led by prominent figures like billionaire and innovator Elon Musk. So, what are the foundations that make this idea, which might at first glance seem like madness, so controversial? And why do some of the world's smartest minds believe it, spending long hours contemplating the possibility that our entire reality might just be a digital illusion? Let's delve together into this astonishing concept and discover the complex scientific dimensions and profound philosophical depths that make the virtual reality we live in a plausible, thought-provoking, and perhaps even somewhat unsettling possibility. Is our life just a sophisticated computer game simulated with extreme precision? Imagine for just one moment that everything your eyes see, your hands touch, your ears hear, and your five senses feel, and even your deepest thoughts and inner feelings is an integral part of an ultra-precise computer program. A program designed and executed by a highly advanced civilization, perhaps technologically millions of light years ahead of us. This scenario, which blends wild science fiction with potential cosmic truths, is not just a plot for a novel or a film. It is the essence of the simulation hypothesis. It's a theory promoted and believed not only by technology thought leaders like Elon Musk, who sparked controversy with his bold statements on the topic, but also by a growing number of prominent physicists and respected philosophers worldwide. So, what are these pieces of evidence, which may seem vague or indirect, that make this idea so highly controversial and debated in academic and popular circles alike? And why do some of the smartest and most logical minds in our world find it convincing enough to believe that we might indeed be mere players in this cosmic digital game? Let's delve deeper into this astonishing concept and together unravel its complex threads to discover the scientific and philosophical dimensions that make the virtual reality we live in a plausible possibility, not just a fictional idea, but a hypothesis worthy of serious study and deep analysis. The simulation hypothesis. Between scientific questions and philosophical depth, a journey through time and cosmic concepts. The idea that our perceived reality is not what it seems, or that there is a deeper, more fundamental level of truth, is not a modern invention. Rather, it is an idea deeply rooted in the history of human philosophy, going back thousands of years. But it has gained an entirely new and astonishing dimension with the accelerating pace of technological progress in recent centuries, especially in the fields of computing and artificial intelligence. A. Philosophical roots, from Plato's cave to Nick Bostrom's hypothesis, the illusion of reality through the ages. To begin to understand the simulation hypothesis, we must go back in time to ancient Greece, where the great Greek philosopher Plato introduced a fundamental idea that changed the course of human thought. In his book, The Republic, Plato presented the famous allegory of the cave, which is a cornerstone for the concept that what we perceive might not be the complete truth. In this allegory, Plato describes prisoners chained from birth inside a dark cave, their faces directed towards a wall. Behind them, there is a burning fire, and between the fire and the prisoners, people pass carrying various statues and figures. The prisoners see the dancing shadows of these objects on the opposite wall and firmly believe that these shadows are the absolute reality, the only truth that exists. They are completely unaware that they are seeing mere faint and distorted reflections of another, more perfect and real reality outside the cave. Could this ancient allegory, which seems simple on the surface, be a very powerful metaphor for our current situation? Are we, in this modern age, prisoners in a giant digital cave, experiencing digital shadows of a higher reality that we cannot directly access or perceive? Is what we experience as daily life, with all its precise details, emotions, challenges, and joys, merely a projection or rendering of something else managed from behind the scenes? This ancient philosophical idea found its way into the modern era, gaining tremendous momentum and a new development at the hands of the Swedish philosopher Nick Bostrom from Oxford University. In 2003, Bostrom revived this idea, but with an entirely new perspective, based on mathematical logic and rapidly accelerating technological development. He formulated the famous simulation hypothesis, which caused a stir in scientific and philosophical circles, presenting a controversial mathematical argument that it is very likely that we are living in a simulation.
Bostrom's argument is summarized in three main possibilities, one of which he believes must be true. Possibility 1. That extremely advanced civilizations never reach the stage of possessing the immense technological capability to create a simulation indistinguishable from base reality. This might imply the existence of physical or computational limits that even the most advanced civilizations cannot overcome. Perhaps there is a ceiling to the computing power in the universe, or there are fundamental obstacles that prevent the simulation of human consciousness in its precise details. Possibility 2. That advanced civilizations that reach this immense simulation capability choose, for some reason, not to create a large number of ancestor simulations, i.e., simulations of conscious people like us, who possess history and memory. These reasons might be ethical, where they might view creating conscious beings in a simulation and subjecting them to pain and suffering as unethical. Or it could be due to reasons related to preserving the immense resources that such simulations would require, or simply due to a lack of sufficient interest in resimulating the history of their ancestors. Bostrom's possibility 3, that we are most likely living in a simulation. If advanced civilizations are capable of creating incredibly realistic simulations, and if there are no constraints preventing them from creating an infinite number of these simulations for scientific research, historical reconstruction, or even entertainment, then it is statistically logical that the chance of our existence in one of these simulations is much higher than the chance of our existence in the original or base reality. In other words, there would be many more simulated realities compared to one base reality. Imagine you have 1 billion counterfeit coins, designed so meticulously that you cannot distinguish them from real ones, and one real coin. If you randomly pick a coin, the highest probability is that the coin you picked is counterfeit. By the same logic, if simulation is possible on a large scale, it is likely that we are inside one. If our human capacity for simulation continues to grow exponentially at this astonishing pace, won't we eventually reach a point where we can simulate worlds indistinguishable from reality? And if so, what prevents another civilization that has already preceded us by tens or hundreds of millions of years of evolution from having already achieved this, and we are now living within one of those complex simulations they created?
B. Physical evidence. Is the universe programmed? Subtle clues in the fabric of reality whispering of a digital possibility. Beyond philosophical abstractions and logical speculations, some contemporary scientists believe that there are strange and unexpected physical observations in the structure of the universe we live in that can be explained more logically and effectively if the universe is a vast digital simulation. These are like flaws, limitations, or even fingerprints in the program code that runs our reality. 1. The quantum nature of the universe, the fundamental pixels of existence and the cosmic refresh rate.
Quantum physics, the branch of physics that studies the smallest particles in the universe, protons, electrons, photons, quarks, etc., shows that the universe at these very tiny levels does not operate smoothly and continuously as we see it in our macroscopic world. Instead, the universe operates at discrete and quantized levels. Energy comes in specific packets, quanta, and space and time have fundamental units that cannot be divided into anything smaller, known as Planck time at approximately 10 to the minus 43 seconds and Planck length at approximately 10 to the minus 35 meters. Some argue that this discrete behavior of reality, where everything is composed of separate units, closely resembles the operation of any computer program or advanced video game. Everything in the game consists of pixels, very small spatial units that make up the image, and refresh rates, separate temporal units that determine the speed of frame display. If the universe is a simulation, it is perfectly logical that there would be a screen resolution, spatial pixels, or a frame rate, temporal units to run reality, in order to conserve the necessary computational resources. 2. The cosmic speed limit, speed of light. Performance limiters in the grand simulation system. The fact that there is an absolute maximum speed in the universe that no physical object can exceed, which is the speed of light, approximately 299,792,458 meters per second in a vacuum, is a very unique and mysterious phenomenon. Why can nothing, not even subatomic particles, move faster than light? Some proponents of the simulation hypothesis argue that this maximum speed might serve as a performance cap or speed limit programmed into the simulation to ensure system stability and prevent crashes or bugs within the simulation. In any complex computer program, there are limits to the speed at which data can be processed, a scene updated, or information transmitted, and the speed of light could be one of these built-in limits that ensure efficient operation. 3. Precise mathematical constants. Amazing parameter tuning by a cosmic programmer? The universe we live in is incredibly, almost unreasonably finely tuned. The values of the fundamental physical constants, such as the strength of gravity, the strength of the strong and weak nuclear forces, the mass of the electron and proton, and the level of dark energy that causes the expansion of the universe, are precisely what they need to be to allow the formation of stars, galaxies, planets, and ultimately, complex life and human consciousness. If any of these constants were to change by even a tiny fraction, some require precision to more than 100 decimal places, the results would be catastrophic. Either the universe would collapse on itself before stars could form, or it would disperse too quickly for matter to cohese, or stable atoms would not form, or life-supporting planets could not form. Is this astonishing coincidence, commonly called the fine-tuning of the universe, merely incredible cosmic luck? Or is it evidence that these parameters and variables have been carefully tuned and programmed by an intelligent entity with the goal of producing a universe capable of hosting consciousness and the emergence of life? It's similar to adjusting the settings of a video game or simulation program to ensure a specific goal or outcome is achieved.
The theory of information as a fundamental building block of the universe as a vast database. Some contemporary physicists, such as John Archibald Wheeler, who coined the term black holes, argue that information may be the fundamental and essential building block of the universe, not energy and matter as we traditionally believed. Wheeler introduced his revolutionary concept of it from bit, which suggests that everything physical and real in the universe ultimately derives from information. Instead of information being a consequence of physical reality itself arises from information. If the universe is information at its core, and if quantum particles are bits of information that can be processed, then this makes the idea of simulation more acceptable and logical, as simulation, by its nature, is a massive and complex processing of information. The universe, in this sense, would be like a huge database that is constantly being run and processed. Potential errors or glitches in the simulation, glimpses of base reality? Although it is very difficult to prove, some speculate that certain phenomena in our lives or unexplained observations could be accidental errors or glitches or fingerprints in the simulation's code. These phenomena might include strong déjà vu, the feeling that you have experienced this situation before, unexplained statistical patterns in the behavior of certain natural phenomena, or even strange personal experiences that cannot be explained by known physics. Some interpret these as a reload of a scene, a correction of an error, or even momentary hacks by the programmer. Of course, there is no strong, proven scientific evidence to support this idea, but it remains a thought-provoking point in the context of the simulation hypothesis and raises questions about the perfection of the simulation. 2. Why does Elon Musk believe in the simulation hypothesis? The story of a futuristic entrepreneur who sees beyond the horizon. It is not surprising at all to find technology giants and futuristic thinkers who push the boundaries of innovation, like Elon Musk, embracing the simulation hypothesis with great passion. Musk, known for his boldness in thinking outside the box and his ability to envision a future for humanity deeply influenced by technology, has stated on several occasions very clearly, the probability that we're in base reality is 1 in billions. This bold statement is not just a random conclusion or a passing obsession. Rather, it is based on a set of observations and assumptions that Musk sees as convincing evidence and a strong indicator that we live within a simulated world.
The amazing evolution of virtual reality, VR games, and computer graphics, a stunning time leap. Musk notes the incredible pace of technological development we have witnessed in a very short period of human history. In just 50 years, we have transitioned from extremely primitive two-dimensional video games with simple graphics like Pong or Space Invaders, which required only a few pixels in simple calculations, to incredibly complex three-dimensional video games with ultra-realistic graphics, and immersive virtual reality, VR, to the extent that they make players feel completely immersed in real worlds. The ability to simulate lighting, physics, materials, and even character emotions in games has evolved incredibly. Musk's logic here is simple and powerful. If we, as a civilization, have been able to achieve this tremendous progress in simulation in just half a century, what can technology achieve after 100 years, or 1,000 years, or 1,000,000 years? If this development continues at its exponential pace, we will inevitably reach a point where we can create simulations so realistic that they are indistinguishable from reality itself. And if we are going to do that, it is logical that another civilization that has already preceded us by tens or hundreds of millions of years of technological development has already done so. And we are now living in one of those complex simulations they created. Artificial intelligence and simulated consciousness. Can a machine feel? Musk and other technology and AI experts anticipate that artificial intelligence will reach a level of development in the near future where it becomes capable of creating true artificial consciousness. Not just a simple simulation of intelligence or behavior, but real conscious entities that live, think, and feel within the simulation. If AI becomes capable of creating conscious simulations with characters indistinguishable from real humans and with real subjective feelings and experiences, then it is logical that we might be one of them. This idea perfectly aligns with Bostrom's hypothesis. If the ability to create consciousness in a simulation exists, and the desire to explore this possibility exists, then the number of simulations that can be created will be vastly greater than the single base reality. The amazing empty space and the absence of alien civilizations. Fermi paradox. Are we alone in this program? Despite the incredibly vast expanse of the universe, which contains billions of galaxies, and each galaxy contains billions of stars, many of which have potentially habitable planets orbiting them, we have not found any conclusive and direct evidence of other advanced civilizations. This cosmic dilemma, which has puzzled scientists for decades, is known as the Fermi paradox. Musk, along with others, offers a possible, albeit shocking, explanation. Perhaps we haven't found any other civilizations in the universe not because they don't exist, but because the simulator or programmer didn't put them in the program we live in. Perhaps we are the only part of the simulation that experiences consciousness or technological development. Or perhaps the expansion packs for other civilizations have not yet been loaded into our specific simulation. Or perhaps simulations that reached a certain stage of development were reset. This explains the strangely and disturbingly silent universe and offers a potential solution to the Fermi paradox from a digital perspective.
3. Criticisms of the theory. Are there serious flaws in the matrix that could lead to its collapse? As captivating, imaginative, and capable of pushing the boundaries of human thought as the simulation hypothesis seems, it faces numerous strong criticisms and difficult questions that weaken its argument and make it, in the view of many, merely philosophical speculation rather than a testable and verifiable scientific theory. Many scientists and philosophers still consider it an interesting idea, but one that lacks empirical basis. No direct and verifiable physical evidence, merely interpretive speculations, not falsifiable facts. The strongest and most central argument against the simulation hypothesis is the complete absence of any direct physical or empirical evidence that can conclusively confirm it. All the evidence presented by its proponents is circumstantial or possible interpretations of existing phenomena, not definitive fingerprints of the programmer. The laws of physics and the fine-tuning of the universe can be explained in other ways that do not necessarily require the simulation hypothesis. For example, the fine-tuning of the universe can be explained by the concept of the multiverse, where countless universes with different physical properties exist, and we simply happen to live in the universe whose laws allow our existence. We cannot conduct an experiment in a laboratory to prove or disprove this theory, which, for now, places it outside the realm of the traditional scientific method that requires falsifiability and experimentation. The problem of consciousness. How can a simulation create genuine subjective experience and conscious awareness? This is one of the biggest philosophical and technical obstacles to the simulation hypothesis. Even if we could simulate a complex human brain with its most precise neural details and process billions of electrochemical signals per second, would this simulation produce genuine consciousness? Would the beings within the simulation feel pain, love, joy, anger, or suffering? Or would they simply be processing data without any true internal subjective experience? The concept of consciousness itself remains a very deep mystery in neuroscience and philosophy, what is known as the hard problem of consciousness, and there is no agreement on how consciousness can arise from matter, let alone from computer code. If our consciousness is merely part of the simulation, is it real in the same way we consider reality? And does it have any meaning beyond the boundaries of the program? The bigger question, who simulates the simulators, the infinite regression of illusory reality? If we live in a simulation, then the logical and at once frustrating question is, who are the entities that programmed the simulation we live in? And is the base reality they live in itself a simulation of a higher reality? This leads to an infinite regression of nesting simulations that offers no definitive solution to the nature of the first reality, but rather postpones the problem and makes it more complex. It is an infinite dilemma that cannot be easily answered and makes the theory less convincing because it does not provide a complete or ultimate explanation for the nature of the first reality or the higher level of existence.
The enormous computational and energetic cost of simulation, unprecedented practical challenges. Even if we assume the existence of an incredibly advanced civilization, running a simulation the size of the universe we see with all its galaxies, stars, and planets at the level of quantum particles that make up matter and energy would require immense amounts of energy and computational power beyond anything we can currently imagine. Where would this energy come from, which might be equivalent to the energy of an entire galaxy? And how could it be maintained for long enough periods to allow the evolution of civilizations within the simulation for billions of years? Some argue that this practical challenge makes the idea of simulation impractical, even for the most advanced civilizations. Limiting scientific research and the pursuit of knowledge. Does it diminish the value of our existence? Some critics might argue that adopting the idea that we live in a simulation could lead to diminishing the value of scientific research, philosophy, and the pursuit of understanding the universe. If everything is just a program run by higher programmers, why should we bother understanding its complex laws or exploring its mysteries? Some might see this idea as potentially reducing the human incentive to explore the unknown, unravel the mysteries of the universe, and pursue knowledge, which contradicts the very essence of the scientific spirit itself. However, this point can be countered by arguing that understanding that we are in a simulation might open up entirely new avenues for research, such as trying to find errors in the code or ways to communicate with the programmers.
Should we really care? The value of existence in a world of mystery and infinite questions. Regardless of whether we are convinced by the simulation hypothesis or not, merely posing this question sparks a profound and very important philosophical and scientific dialogue. It is an invitation to reflect and reevaluate our fundamental assumptions about reality. Even if we are indeed living in an elaborate simulation, this does not necessarily diminish the value of our existence, or the experiences we live, or the emotions we feel. Pain, love, happiness, sadness, the search for knowledge, building human relationships, creating art, and striving to achieve our dreams, all these experiences have their own unique and essential meaning for us as conscious beings, regardless of the nature of the external reality that contains them. If this simulation is designed well enough that we cannot distinguish it from real, original reality, then does the difference truly matter in our subjective experience? As Elon Musk famously stated, "If life is a game, let's play it the best we can." This phrase encapsulates part of the philosophical essence of this theory. Even if we are merely entities in a complex computer program, our goal may still be to explore this reality, understand its laws, realize our full potential within it, and strive to improve our existence and the existence around us. The human curiosity that drove us to ask this bold question about the nature of reality is the same curiosity that will lead us to explore the universe, whether that universe is real or simulated. So, are we living in a simulation? Perhaps the near or distant future will reveal the answer, with the immense and continuous developments in quantum physics, artificial intelligence, and simulation technologies that are accelerating at an unprecedented pace. But until then, the question remains one of the most exciting and challenging mysteries in the history of human thought, constantly pushing us to ponder the deepest secrets of existence and making every moment we live a reflection on the nature of this astonishing reality we call life.